Welcome back, everyone. I'm Professor Rhett Smith from ProtonGuru.com. Today we're going to talk about Lesson 4.6 and continuing our study of aromatic molecules. We learned about benzene as sort of the prototypical aromatic molecule. So I want to go over some of the nomenclature. How do I name benzene compounds that have just one substituent on them? Some of this nomenclature is pretty straightforward, where you just use benzene as the parent chain and you put the name of the substituent out front. So fluorobenzene, chlorobenzene. And in these cases, you really name these just as if they were cyclohexane derivatives. If I had cyclohexane here, so if I didn't have the double bonds around the ring, it would just be fluorocyclohexane. And if there's only one substituent, you don't need a number to tell you where that substituent sits, because by definition you give it the lowest possible number on the parent chain. And if it's a cyclic compound, there's only one substituent, well, it has to be at position 1. So scientists don't use this redundant, unnecessary one to tell you that. So if you put halogens, you just say fluorobenzene, chlorine would be chlorobenzene, if you had bromine it would be bromobenzene, iodine, iodobenzene. Same goes for alkyl groups. You have ethylbenzene. Even more elaborate alkyl kind of groups, you can name isobutylbenzene, or you could name the substituent in parentheses using its IUPAC name of 2-methylpropylbenzene. And as we go through section 4 of the book, we'll talk a little bit about this new functional group we haven't seen before if you're going consecutively in this course. This is the nitro substituent on benzene. So this compound is nitrobenzene. If you think about the nitro substituent's Lewis structure, it's a little unusual in that you actually have a formal plus charge and a formal minus charge on two of the atoms in the structure. Although, since they cancel out, you don't need to draw any formal charges on the overall functional group. So we'll see this nitro substituent a little further on in this section as well. Now when benzene is not the parent chain and instead is considered as a substituent, we call it a phenyl substituent. If we have a methyl group, it's methane named as a substituent. If we have an ethane, but it's a substituent, we call it ethyl. So phenyl is what you would call benzene. And when would we see that? Well, let's say we have this long chain, which is 1, 2, 3, 4, 5, 6, 7, 8 carbons long. Well, if there's a benzene substituent here, well, the parent chain that's longer is the octyl chain, right? The benzene only has 6 carbons. So you would pick the octyl chain as the parent chain and say octane. You have a benzene as a substituent at carbon 4, so you would name that benzene as phenyl, so 4-phenyloctane. And of course this is chiral, so if you were given a specific configuration, you'd have an R or S label out front as well. But this shows you when you might need to name benzene as a substituent. Now a lot of benzene compounds that have one substituent were discovered a very long time ago and became important in different industrial processes. So some of them were given common names before people invented sort of the systematic way to name compounds. So if you have an OH on a benzene, you don't name it benzene alcohol or benzenol or something like that. Instead, you use the common name, the name that was given to it a long time ago, and you call it phenol. Now this name kind of tells you that it's a phenyl group with an alcohol, so that name kind of makes sense. The next one I want to show you introduces another new functional group, the nitrile functional group. It is a C triple bond N compound where it's attached to the species, the parent chain, with a single bond to the carbon. And this compound is called Benzo Nitrile, which again, once you know what the nitrile functional group is, it says benzo, referring to benzene. That name kind of makes sense as well. If you have an aldehyde functional group on a benzene, you call this benzaldehyde. The name kind of tells you what it is. If you note this is a carboxylic acid functional group, you have this oic acid attached to benz, so benzoic acid. Then you have this group that has the phen part in it, referring to the phenyl group, and the -one referring to the ketone. So it tells you there's a ketone with that -one ending. With the phen part of the word, it tells you that you have a phenyl group. What's this aceto part of the name? Well, an acetyl group is this group here. And you may remember that this group, this acetyl group with an OH on it, is called acetic acid, or this anion is an acetate anion. So we've kind of seen that word part before, and here we're applying that word part to make acetophenone. to tell you what two groups comprise this ketone. So these compounds shown in the top row all have names that kind of relate the structure to the names. But this lower group of compounds have common names that were given to them a very long time ago and have stuck even in the official names for these compounds. And they don't necessarily tell you what functional groups are in the compound. So we want to make sure we commit these to memory. If we have a simple amine, NH2, attached to a benzene, this compound is referred to as aniline. If we have an alkene attached to the benzene, it's styrene. So at least the ene tells you it's an alkene. But the styr part doesn't necessarily tell you that it has benzene in it, right? So we're going to have to memorize this name. Anisole refers specifically to benzene that has an OCH3. So it's this ether group with a phenyl on one side and a methyl on the other. And then we have toluene, which is simply a benzene with a methyl group. So these five, I think, are the most important monosubstituted benzene compounds that have these common names that need to be memorized. Now when we start learning about how to make polysubstituted benzene compounds, we'll learn how to name those. But for now, these naming conventions and knowing the names of these particular compounds on this slide will get you through the next part of the material.